So again, we're given general form, but it wants something from the vertex. We're like, it would sure be nice if it was in standard form. So we're going to have to change it to standard form. And we have fractions again. So we're going to have to pull out that 1/5. But this is where we get some mental math happening. How do you pull 1/5 out of 2? Okay? 1/5 out of 1/5, you're like, I got this. I can pull that 1/5 out. But how do I pull a 1/5 out of 2? And sometimes I actually think about working backwards here. I think, well, if I distributed 1/5 times what is 2? That's an easier way for me of thinking than pulling 1/5 out of 2. My brain goes, no, don't want to think about that. But 1/5 times what is 2 is 10. Yeah. So, do you see, is that a little bit easier of a way of thinking of things? Yeah? That makes sense, right? But pulling a 1/5 out of a 2, it's really asking if you took 1/5 and added them up, how many would it take to get to 2? 1/5 plus 1/5, well, 5 of them would make 1, 10 of them would make 2. 1/5 out of 3 would be 15. Because you want to think backwards. You say, this is much easier for me. 1/5 times what makes 2? And then you're like, oh, that's 10. Rather than trying to pull a 1/5 out of a 2. So then we got a space here. And we still have the -1. And the space there.
I'm curious about, like, where they change their C's all the time. How could we work? I wasn't very picky about that.
And I saw on an AP video that they're not picky about that.
The other thing, I think.
But I like that.
I like that, but the thing is, then you get to C4, C5, and
Well,
so
and then
whatever.
I show them in a question when you integrate both sides.
You should have a C on each side, really.
You should, but then you can't have them different.
Yeah, and
Otherwise
then you
cancel
combine those to be C3,
Yeah.
and you have to define it every time. This is another one. Here, they put plus or minus, but because it's a constant, really, you wouldn't have to put plus or minus. It's kind of like the same argument. It's a constant.
But the constant would be the same. But when you find a particular solution,
It would be different. So here you have to have it.
you have to have it
Okay.
until you, like, you still need it until you plug it in. I think it might even stay there. Should be.
Since C value is affected by the cross, you can just attack it anywhere you process. That's before the end. That's something. Yeah, I'm just curious because I know when I taught, I wasn't that careful, but maybe it's just.
Yeah, with the C's, they don't take it out. The other thing I wondered, in solving a particular solution, you always have to get y by itself. Like in the one question, the last one in the exam, it says y equals f of x.
Like there's actually questions on the exam that tell them not to put y. Like it actually specifically says don't get y, which is kind of interesting.
Yeah. All right, I paused it. That conversation won't be on the video, but you'll have a nice, quiet time. All right. So, things are actually pretty good in here for the squared part, because this isn't a fraction. That's a nice 5. This is going to be plus 5. That's going to tell me here I have to add 25. And that 25 gets hit by the 1/5. So we're actually adding 5 to compensate. I have to subtract. And then I get -6. So what is my vertex? Opposite sign here would be -5, comma -6. And the question is asking about the y coordinate. So I should show that I've read the question and answered what they wanted to. The y coordinate on my vertex is -6. Just one question from this one. Number 7.